Presentation. My name is Mark Scythian. The date today is January 15, 2025. So the title of this presentation is wireless AC electricity possible? Yes and no, and here is why. Okay, now we know about the Wardenclyffe Tower that was built by Nikola Tesla in the early 20th century and the funding from J.P. Morgan. However, the actual story is not as sensational or dramatic as it seems, because Nikola Tesla had actually not completed the project, and Morgan and everybody in industry probably would have liked to shelf their own wireless AC to maximize, let's say, oil profits. Okay, now it's another question, would they have given that to the people? Maybe, maybe not. So it is not conspiratorial as it is a function of logistics. So changing AC sine wave voltage and current from the 60 or 400 cycles per second to, let's say, 30,000 cycles per second is here, and let's say we push it with 2200 volts AC RMS, we could indeed then convert that type of power, AC true power, into an AC harmonic signal through an oscillator. And so here we've successfully transmitted the high frequency AC sine wave. Let's say the voltage. There should be like two of them going, but let's say we just isolate the voltage sine wave. This would indeed act in an electromagnetic oscillation or spectrum, provided a magnetic emission system was containing it. So Nikola Tesla did pass very high voltage and current through his body while in a magnetic field that he built, and so to the observer it would then bring lighting or luminescence from the trapped photons in the magnetic field, successfully transmitting the high frequency AC through the atmosphere in free space. But once one comes out of that magnetic field, they will get electrocuted. Their power factor will be very high. They'll probably experience instantaneous brain depolarization, like an electric chair execution, and then their power factor will drop. Heat will then take over. The power will then not conduct, but will change into heat, and then the power factor drops, and the person will probably catch on fire and get charred. So without that magnetic field to contain something quite dangerous as wireless AC, we would be running into a serious problem. So of course all the mathematics and physics, including the chemical, physical, chemistry analysis, could be completed to then render the project extremely dangerous. So this is where we get the mindset that those people working on wireless AC are kind of crazy. And yes and no. So it is feasible to actually send wireless AC, but actually building magnetic emitter systems across the entire global infrastructure would more than likely render all the other systems obsolete, including possible unintentional electromagnetic pulses that just destroy the electric grid. So the Wardenclyffe Tower project, that would have to be continued, all the existing infrastructure torn down, and then some sort of a system, perhaps through the World Wide Web, that would contain wireless AC through a type of cloud-based magnetic enveloping over the planet. But then that is just going to open up a new can of worms. And so then it would render everything we have slightly off in the frequency domains for AC. So whenever possible, when designing AC systems, it is very ideal to make a design that's functional, reaching, if possible, a power factor of 1 resonant circuit, so you can actually source from AC, and then all your devices function as if it's DC because power factor is 1. There wouldn't even need to be much of a rectifier diode bridge to convert AC to DC if you just built resonant circuits. So the system, the grid, likes to do its best to reach a power factor of 1.0, but it's very idealistic. And so then we have different stage systems, 2-stage, 3-stage, transformers, etc., because things start to drop off, and then we have the frequency differential, and then we have a lot of problems. So we could isolate this down into a small model and just observe the entire grid from that perspective, and then it's a no-go because the design will render the project a complete disaster or failure, and so it's denied. It's not approved, right? But if we can just look at a scaled down model here, let's say we built a resonant AC parallel electrical circuit, achieving a circuit frequency equal to the resonant frequency, we would then reach the calculated power factor of 1.0. We do all the calculations. We come to 5.3 and 5.3 microhenries and microfarads for inductor and capacitor, and then a resistance equal to the, or impedance equal to the resistance. And so we check that on the top, the inductive and capacitive reactances, and we checked everything. They all come to 1 ohm, and so we actually just have 1 amp pushing this whole, we're just pushing 1 amp through at higher voltage and higher frequency, and so we get an idea that is a functional circuit, and then we match that to the harmonic oscillator specifications, and this then reaches a pretty dangerous discharge of emissions. But if it contained inside a magnetic emitter, then we have the ability to actually send that to a receiver and then step it back down to 60 cycles per second. So it's feasible, but so technically yes, but then having a harmonic oscillating grid with a magnetic field, that's so we'll say no. So now it becomes very dangerous, and then some of the other scientists and engineers will pretty much just say it's crazy to do this wireless AC, or that it's kind of something crazy Nikola Tesla thought about, but it is very feasible. However, it's not supportable with our grid, not for many, many decades. And so now everything that's been developed is ruined. So the answer is yes and no. And then lastly, there was an aerospace engineer, PhD, I think in Tennessee or in Texas, that did actually run some radio-controlled DC electric boats on the water by building a magnetic emitter and then actually sending out a AC signal that rectified into DC at the remote control boats, toy boats, and then it ran on DC power. And there's actually a YouTube video documenting that, but that's a far cry from actually electrifying an AC wireless system for the entire domestic and international AC electrical power grid. That's kind of really not going to work. So technically, theoretically, it is a yes, but supportability, no. And so is wireless AC electricity possible? Yes and no. And this presentation has described why that answer is yes and no. Thank you for watching this presentation, and have a great day.